Okay, 1.1 relations and functions. We have some vocabulary to go over. First, relation is simply a set of ordered pairs. In a relation, we have a domain and range. The domain is a set of all abscissas. Probably never heard that word, but that's basically just the first element, okay, in an ordered pair. In the range, it's a set of all ordinates, or the second element in an ordered pair. So domain represents the first, range represents the second. And we often represent those with what letters? X and Y is correct. So the domain would be the X, and the range would be the Y. Correct? All right, let's take a look at this example then. Following data gives the amount of rain brought by unseeded and seeded clouds. So we have a data set. Give you a couple seconds to copy that. Take a look at the first question we need to do. State the relation as a set of ordered pairs. An ordered pair has two elements, a first and a second, abscissa and an ordinate. So it'll be the first ordered pair. Somebody with a hand. Good. Right. Very straightforward. So we can do that with the rest of them. 4.9, 17.5, 4.9, 7.7, 11.5, 31.4, 17.3, 32.7, 21.7, 40.6, and 24.4. And 92.4. So pretty straightforward. Taking sets of data, turning them into ordered pairs. Any questions on that? Okay, I'm going to go to the next page. 2. State the domain and range of the relation. Okay. Well, there are sets of data. So the domain equals a set, the range equals the set. Of what? Well, domain represents X, range represents Y. The vertical line represents such that. So domain is equal to a set of X such that, here comes the numbers. So you guys are going to have to tell me what the numbers are because the data is on the other page. Who's going to tell me the numbers? Or I could just flip back and forth. What do you got? All of the domain. Whatever you feel is the domain. Okay? Okay? Here's a great question. I see 4.9 twice. Do we repeat 4.9 or do we not? No. You told me yes. You told me to write it twice. Do you repeat an element or not? Do we have to repeat something? No. So we don't need 4.9 twice. You only need it once. Okay? How about the range? Somebody else. What numbers are we using for that? Good. What was the last one? Here's another good question. Should we put them in order? Because that's not. When you list the set of domain and range, should you put it in a certain order? We know we can't repeat, or we shouldn't repeat. Should we have them in order? Like the domain is in order from smallest to largest. The range is not. What do you think? Yes. Yeah, we should. We should reorder it in ascending order, okay? We won't do that right now, but yes, we should. Okay? Okay, let's graph. How do we graph? I forget. You guys all forget too? I mean yes. How do we graph? These numbers. What numbers? And what? I agree with you. We've already set this up. We put the data into a certain form that we can then graph. What did we do? Ordered pairs. We can graph ordered pairs. How do you graph an ordered pair? For instance, I think the first ordered pair we had was 1, 0, and 4.1. How would I graph that? Which one's the x? I agree. This is the x-axis. So this makes this one what? The y. Which is the x? Which is the y? What number? What number is the x? Which one's the y? Yeah, all ordered pairs are x, y. Remember, the domain represents the first element. Okay. Or x. So tell me, how do I graph 1.0, 4.1? I go over 1. Where do I start? At the origin, or where the two axes cross. And I go which way? Right 1. And then which way? Up 4.1. So that's where I put my dot. Yes. Yeah, absolutely. Okay, 1.0, 4.1. First number represents how far left or right. Second number represents how far up or down. Okay, so let's graph a couple more. We don't have to graph all of these. The next one I have on my list is 4.9. So 1, 2, 3, 4, 5. So about here, 4.9, 17.5. So next one is going to be 4.9, 17.5. Do we get the idea? Do I need to graph some more? Okay, to graph the relation, you need to graph all points. Okay, so there's 1, 2, 3, 4, 5, 6, 7. All right. Considering my graph, the way I drew it, there's no way I'm going to be able to graph after the next one. I'm going to have to go all the way up to 92 on the vertical, right? So that's something that you should consider when you're graphing. If I have to go all the way to 92, you need to decide how you're going to label your axes, because the way I did it, obviously we're not going to be able to see the entire graph, right? So you want to look at your entire relation, your entire data set, before you decide to start just tossing lines up like I did. All right, so what I probably should have done is I probably should have maybe counted by fives. So 5, 10, 15, 20, 25, 30, 35, 40, 50, 55, 60, 80, 90. Okay, now I'm pretty close to where I need to be, right? Problem is, the points that I drew, I have to redraw now. And how far on the X, how large do we get on the X? What's the largest element in the domain? So I have to go all the way at least to 25, right? Again, the way I'm counting by ones, probably not going to make it. So maybe we count by twos or threes. Let's see if we can make it by twos. So we got 2, 4, 6, 8, 10, 20. All right, 26. So that scale is probably going to fit us a little bit better. Now I can fit all my data into this graph. So quickly I'll draw these. 1.0, 4.1, 4.9, 17.5, 4.9, 7.7. And without a grid, my accuracy is probably going to be slightly off. But you get the idea of what the relation looks like. When you graph things like this, we start looking for patterns. Okay, if our data fits a specific pattern, we can then put it into the form what we call as a function. Okay, so we do some data analysis. Looking at this pattern here, it looks like it's traveling in a positive direction, so it has probably a positive slope if we're looking at lines. Positive correlation is another thing you might call that. Okay, it's not quite a straight line. It's not really fitting a specific pattern, so we could probably come up with some different functions to approximate what this relationship is doing. Okay, so that's where the next vocabulary comes in, a function. A function is specifically a relation in which each element of the domain is paired with exactly one element in the range. I didn't write it down this way, but you may have heard for every x there's exactly one y. Maybe a little bit more of a definition you've heard in the past. For every element in the domain, that's for every x, it's paired with exactly one element in a range. It's exactly one y. So, is that relation a function? No, why not? 4.9, which is an x, is connected to how many y values? 2. 4.9 goes to 17.5 and 7.7. So for that 1x, there's 2 y's, not a function. Another way we can look at that is, actually I wanted to skip this, there we go, a vertical line test. I'll come back to that top part. So if you have a picture and you want to know if it's a function or not, you can simply just try the vertical line test. If every vertical line drawn on the graph of a relation passes through no more than one point, and the relation is a function, it is only allowed to pass through the graph once. Vertical line. All right. So vertical line test, as stated, vertical line passes through the graph more than once. You look at A, these horizontal lines, that's like represents shading. That's the best I could do. So this is all shaded. So if I draw a vertical line through this, is that passing through more than one point? You have to shade it, it's passing through a whole bunch of points, right? Because all of the shaded area counts as part of the graph. Okay? How about on graph B? Is that ever going to hit more than once? No, that's a good one. That's fine. And if we go back to our relation, we said that we didn't feel it fit the definition of a function, and you can see right here in the graph, it passes through those 2 points. Okay, got to draw a little straighter. You can see that it definitely passes through those 2 points. Does not pass a vertical line test. Okay, so simply just 2 points does not work. All right. Getting back to this example, state the domain and range and tell me whether it's a function or not. So what's the domain? Yes, answer it. It's easy stuff. What do you get? What is it? -3, about 2, 4. Right? We're going to try to reorder them. Right? Yes. Yeah, we want them in ascending order. All right, what's the range going to be? Good. Is it a function? For every x, there's exactly one y. Do we have any repetition? No. So we're good. Well, depends what's repeating. For instance, do I have an x value that shows up twice? Okay. Do I have a y value that shows up twice? Okay, so that should be good. Let's look at the next one. Okay. Okay, so what would the domain on this one be? Close. First, we want it in order. So -9, 4, 9, okay. And we don't repeat, right? How about the range? Anybody? Good. Okay. A couple ways you can look at this. The x is smaller than the y. The domain is smaller than the range. That's something's going on there. Okay, because we should have the same amount. So there's obviously some repetition. Okay, 4 shows up twice. Okay, and it's not going to the same point, because if we did, why would you write the same point twice? Okay. So is that going to pass the vertical line test? No. Is for every x, is there exactly one y? No, there's actually 2. There's 1, 2, right? We have 2 different y's going to the same x value, to the same 4. So do you understand why this is not a function? This one is not. This one is. Okay? Any questions? We talked about the vertical line test. Function notation. If we determine that it is a function, it passes the proper tests, it fits the definition, we can now write it in the notation f of x, or whatever letter. It might be g of x, or h of x, or whatever they decide. In this case, f of x. F of x is a substitution for y in an equation. Okay? So f of x is equivalent to y. We have a function. F of x equals 3x cubed minus 7x squared minus 2x. Again, this represents y. Okay? So what does f of negative 4 mean? What's that tell us to do? Because you're going to see this on the SATs. I guarantee it. They're starting to use this notation. You should know what to do with this. What's that tell you what to do? Correct. See, f of x, what are we saying x is? We're saying x is equal to negative 4. We want to know what f of x is, so we're really looking for what's y. That's really what we're looking for here. What's y when x is negative 4? Well, let's find out. F of negative 4, or y, is equal to 3 times. Every time you see an x, you put a negative 4 in. That's all that means. So, any super geniuses can do that in your head? Anybody have a calculator? I do. So let's type that in. So we got 3, and we're just going to type in exactly as we see it. Negative 4 to the third minus 7, negative 4 squared minus 2, parentheses, negative 4. Graphing calculator, very nice. I can type in exactly as you see it. We end up with negative 296. Right? Pretty sure that's what it was. Negative 296. Okay. So what does that mean? Well, that's our answer, but also represents a point. So we could say that negative 4, negative 296 is a point on that function. Do you understand that? That's what that represents? You have an x, you have a y, it's a point on the function. So what are we going to do with b then? This is where people start going crazy. Oh, there's a letter. Ooh. Don't look at C then, because you're going to probably lose it. Okay? Do not fear plugging in a letter. Same thing you do with the -4 is the same thing you're going to do with the A. If I want to know what h of A is, I simply want to put A wherever you see an x. So it's simply going to be 3a to the 7th minus 10a to the 4th plus 3x minus 11. And that's it. Done. Okay, it's difficult to write that. I mean, I can write it as a point if you want. A, comma, 3a to the 7th minus 10a to the 4th plus 3a minus 11. Why? It's rare to see something like that. Usually we wait until we have numbers to make points. That's what it represents. This is your x, and this is your result. This is your y. Does everybody understand that? Anybody not understand that? Okay, well then someone's going to tell me how to do C then. Since you all understand. What is g of x minus 5 if g of x equals x squared minus 7x plus 4? Yes, the brave one is raising his hand.
X minus 5 squared minus 7 times 4.
I liked how you used the quantity here if you forgot to say quantity here. I knew what you meant, though. That is correct. Okay, wherever you see an x, okay, this whole thing goes. So, the quantity of x minus 5 squared minus 7 times the quantity x minus 5 plus 4. Can we leave it like that? Oh, you could, but that's not good form. All right, so we should multiply this out. So what does x minus 5 quantity squared mean? Well, it means x minus 5 times x minus 5. We can distribute the -7. So what do we do with this first two here? Because I've often seen people say, oh, quantity squared, oh, I can distribute that square in. That's no problem. That's illegal. Seriously, think of it as breaking a law. That is illegal. You cannot do that. You cannot distribute across a plus or minus. You can distribute exponents when you're multiplying or dividing, but not when you're adding and subtracting. So we have to, what do we call that? FOIL. So let's FOIL. First, outer, inner, and last. I'm just going to add these two together. FOIL. First, outer, inner, last. And then we just combine like terms. We got x squared minus 10x. Oh, actually, we got more than that. Minus 17x plus 64. So that is what g of x minus 5 is equal to. Any questions?